The job description of an industrial engineer centers on the optimization of systems, processes, and operations to improve efficiency, reduce waste, and enhance productivity. These professionals are tasked with designing, developing, and refining integrated systems that involve people, machines, materials, information, and energy. Their work spans across various sectors, including manufacturing, logistics, healthcare, finance, and service industries, where they strive to create better methods of production and service delivery. Industrial engineers combine engineering principles with business acumen to assess current practices and identify areas of improvement. They work to streamline operations, reduce costs, and enhance the overall quality of outputs, often leading cross-functional teams to implement innovative solutions. Their focus is not only on machinery and technology but also on the human aspect of production, ensuring that systems are both efficient and user-friendly. Through data analysis, simulations, and mathematical modeling, industrial engineers help organizations meet performance goals while maintaining safety standards and regulatory compliance. Their contributions lead to higher profitability, better resource allocation, and sustainable operations, making them valuable assets in highly competitive industries. Role of an industrial engineer. The role of an industrial engineer is to evaluate and improve complex systems that integrate people, materials, equipment, and processes. These professionals work at the intersection of engineering, operations, and management, applying scientific methods to address inefficiencies and bottlenecks in production and organizational workflows. One of the central responsibilities of industrial engineers is to conduct time and motion studies. They observe work processes, analyze how tasks are performed, and suggest improvements to reduce time, effort, and cost. This may include rearranging production layouts, introducing automation, or redesigning job roles to increase efficiency without compromising quality. Industrial engineers often collaborate with departments such as manufacturing, supply chain, quality control, and human resources. In a manufacturing setting, for instance, they may work closely with production managers to implement lean manufacturing techniques that minimize waste. In a hospital environment, they may help optimize patient flow or resource scheduling to enhance care delivery. In many organizations, industrial engineers also play a critical role in implementing and maintaining quality management systems such as ISO 9001 or Six Sigma. They use data-driven approaches to monitor performance indicators, identify defects or inefficiencies, and suggest corrective actions. Problem-solving is a core part of the industrial engineer's role. Whether it's reducing operational costs, improving ergonomics for workers, or increasing output with existing resources, industrial engineers approach each challenge with a structured, analytical mindset. They often lead or support project teams to ensure that solutions are both technically sound and economically feasible. Responsibilities of an industrial engineer. The job description of an industrial engineer includes a wide array of responsibilities, all centered around improving organizational efficiency and effectiveness. A primary responsibility is to analyze existing processes and identify opportunities for improvement. This begins with collecting data on production rates, material usage, labor input, and workflow sequences. After thorough analysis, industrial engineers develop models and simulations to test potential improvements. They may use software such as AutoCAD, MATLAB, Arena, or Minitab to visualize layouts, assess production flow, and predict outcomes. Based on their findings, they propose changes such as modifying equipment placement, revising scheduling strategies, or automating repetitive tasks. Industrial engineers are also responsible for developing and documenting standard operating procedures, SOPs. These procedures ensure consistency in operations and help in training new employees. They must consider safety standards, ergonomic guidelines, and regulatory compliance while creating these instructions. Another important responsibility is cost analysis. Industrial engineers evaluate the financial impact of proposed changes, calculating return on investment, ROI, payback periods, and long-term savings. They work with finance teams to build business cases that justify capital expenditures or process adjustments. Inventory management often falls under the purview of industrial engineers as well. They help determine optimal inventory levels, reorder points, and storage methods to reduce holding costs while ensuring product availability. In supply chain operations, they may work on route optimization, vendor selection, or demand forecasting. In service industries, industrial engineers focus on customer satisfaction and service delivery efficiency. For example, in a call center, they may analyze call handling times and suggest staffing schedules that match call volume patterns. In healthcare, they may work on reducing patient wait times or improving the utilization of medical equipment. Documentation and reporting are ongoing tasks. Industrial engineers maintain detailed records of process changes, performance metrics, and continuous improvement initiatives. These records are used to track progress, share best practices, and support audits or certifications. Skills and qualifications required. To succeed in the role of an industrial engineer, a diverse set of technical and soft skills is necessary. Foremost among these is analytical thinking. Industrial engineers must be capable of dissecting complex systems, identifying patterns, and devising effective solutions. A strong foundation in mathematics, physics, and engineering principles is essential. Industrial engineers must be proficient in statistical analysis, probability, operations research, and optimization techniques. These skills help in modeling systems, conducting simulations, and interpreting data accurately. Proficiency in software tools is also critical. Familiarity with CAD programs, e.g., AutoCAD, simulation software, e.g., Arena, Simio, and statistical packages, e.g., Minitab, SPSS, enhances an engineer's ability to develop and evaluate solutions. Knowledge of programming languages like Python, R, or SQL is increasingly valuable in data-intensive roles. Project management skills are important, as industrial engineers often lead improvement initiatives that involve cross-functional teams. They must be able to define project scopes, set timelines, manage budgets, and report progress to stakeholders. Certifications such as PMP, Project Management Professional, or Lean Six Sigma, Green Belt or Black Belt, can be advantageous. Communication and interpersonal skills are key to success. Industrial engineers need to work collaboratively with individuals from various departments, present findings to management, and train personnel on new systems. The ability to convey complex technical information in simple terms is essential for gaining support and ensuring successful implementation. A bachelor's degree in industrial engineering or related fields such as mechanical engineering, systems engineering, or operations research is typically required. Some roles may prefer candidates with a master's degree or specialized training in areas such as supply chain management, data analytics, or human factors engineering. Work environment and career outlook. Industrial engineers work in a variety of settings depending on the industry. They may be found in manufacturing plants, logistics hubs, hospitals, consulting firms, or corporate offices. The job often requires a mix of fieldwork and office-based analysis. Site visits are common to observe processes firsthand and gather relevant data. Most industrial engineers work full-time, with standard office hours. However, certain projects may demand extended hours or shift work, especially in industries with 24/7 operations like manufacturing or healthcare. The career outlook for industrial engineers is positive. According to various labor statistics, demand for industrial engineers is expected to grow steadily, driven by the need for cost reduction, productivity improvement, and quality enhancement. Organizations are increasingly relying on data and analytics to inform operational decisions, further elevating the role of industrial engineers. With experience, industrial engineers can advance to supervisory or managerial roles such as operations manager, process improvement manager, or director of engineering. Others may transition into specialized roles in supply chain, quality assurance, or business analytics. Those with entrepreneurial aspirations may also move into consulting or start their own process improvement firms. Conclusion. The job description of an industrial engineer reflects a dynamic and impactful role that bridges technology, people, and processes. These professionals play a vital role in optimizing operations, enhancing quality, and driving efficiency across a wide range of industries. From analyzing workflow patterns to implementing automation and reducing operational costs, industrial engineers make organizations more competitive and sustainable. Their ability to merge engineering principles with strategic thinking makes them uniquely positioned to tackle modern operational challenges. Whether working in a factory, hospital, logistics center, or office, industrial engineers create value by designing systems that work better for everyone involved. As businesses continue to seek leaner, smarter, and more agile operations, the role of the industrial engineer becomes ever more critical in the modern workforce.